Okay, in today's lesson and recording, we're going to be learning how to draw ionic bonds using the Lewis dot structures. So, some things we need to have out with us to do this. We need to have, obviously, this worksheet will be our further example. We're going to need our periodic table and also our notes to help reference on how we draw an ionic bond. So an ionic bond is a bond between a metal and a nonmetal. It involves a transfer of valence electrons, so we're going to have to draw the Lewis dot structure. We'll have to first draw the symbol of each element, look up their charges, do the crisscross method to get the formula, and then based on how many atoms of each we have, we'll have to draw those out and transfer the valence electrons from the metallic atoms to the non-metallic atoms. So here we go. We're going to start off with number 1, gallium and nitrogen. So if we looked up gallium on the periodic table, it is Ga, and Ga has a +3 charge. So here's Ga right here, and a +3 charge. And then we have nitrogen, the nonmetal, which is N, and nitrogen has a -3 charge. That's the charge number. So to get the correct formula, we are going to crisscross these numbers down. So our new formula should read Ga3N3. Now, because these subscripts are matching, you can actually reduce that down to GAN. So what that means is we are going to just draw one atom of gallium and one atom of nitrogen, but we have to now include their valence numbers, their valence electron numbers. So off to the right, here's our one atom of gallium, and our one atom of gallium has 3 valence electrons. So we'll put 3 electrons around it. 1, 2, 3. Now our one atom of nitrogen we'll draw off to this side, and nitrogen will have 5 valence electrons. So we'll draw 1, 2, 3, 4, and 5. We'll double up there. Now, the metal wants to get rid of all its valence electrons to become stable, while the nonmetal wants to get that octet rule. It wants to be able to have 8 total electrons. So we'll draw the transfer of electrons. So we'll draw this electron, will get transferred over to this side. So now it has 6. This electron will get transferred over here. Now it has 7. And this very last electron will get transferred all the way over to this side, where it now has 8. So this bond becomes stable. Gallium got rid of all 3 of its valence electrons, while nitrogen had 5, was able to gain 3 more, so it has 8. So that's an example of how to draw a Lewis dot structure. If we do one more, we can do phosphorus and potassium. So potassium, if you look on your periodic table, is letter K with a +1 charge. So we'll draw K with a +1. And then phosphorus, which is over here, the nonmetal, is P with a -3 charge. So we'll put P -3. And we will crisscross down. The 3 goes to the potassium, while the 1 goes to the phosphorus. So your new formula actually reads K3P. So what that means is you have 3 atoms of potassium and 1 atom of phosphorus. So we'll go ahead and draw that out to show the transfer of electrons. So we'll draw 3 potassiums, K, K, and K, and 1 phosphorus. We'll put the P over here. Now, each potassium, the Ks, are going to get one valence electron. So there's K, one valence electron. So we're going to put a dot above it. So one there, and one there. Now for phosphorus, phosphorus is letter P. It gets 5 valence electrons. So I'm going to do it like this. So we're going to go 1, 2, 3, 4. And to make the drawing easier, I'm going to put the fifth one over here. So now, each potassium wants to get rid of its one electron. So this one will get transferred over there. So there's 6 electrons. This one will get transferred to this side. There's your 7 electrons. And the very last one will get transferred over here. Now it has 8 electrons. So the bond is now stable. Each potassium got rid of its one valence electron. And now the phosphorus has a total of 8 by gaining those 2, 4, 6, 8. And so there's 2 examples on how to draw ionic bonds using the Lewis dot structure.